everybody. Welcome back to another presentation of Mars Revealers, Mars Anomalies, and Archaeology. And today we have an intensive study and analysis of a known controversial feature found on Mars called the Pyramid of Candor, testing the artificial structure hypothesis. And we must all understand something. That throughout the history of planetary exploration, Mars has repeatedly challenged our expectations. Every new spacecraft has transformed our understanding of this remarkable planet and has revealed a world proposed to be shaped by volcanism, water, wind, impacts, as well as vast amounts of time. Nearly every region of Mars has now been observed in extraordinary detail. But occasionally, a single landform emerges that raises an entirely different question. Not because it proves anything extraordinary per se, but because it deserves to be measured. And this video study asks us all to look more carefully. So, our investigation takes us deep into the Candor region of Mars, which is a part of the Great Canyon systems within the Valles Marineris. So that's this area right here. All right, here's Candor, here's Melos. So, all right. Now, one of the great, again, canyon systems within the Valles Marineris, from end to end, if I can zoom out without my big head in the way, from end to end over here, way over here, is approximately the width of the United States. And it goes up to 4 miles or more deep. So it's, you know, again, really incredible. It's the greatest, what they call canyon system within the whole entire solar system that's ever been, visioned on any other planet. Again, in our solar system. But as extraordinary as it is, this landscape, it appears to have experienced billions of years of natural geological evolution, they like to say. The evolution. Massive landslides, wind erosion, layered, sedimentary deposits, fracturing, collapses, and possible fluvial scarring and erosion, as well as continual reshaping over vast amounts of time by the Martian environment. At first glance, it appears, to be exactly what planetary geologists expect to naturally find. It's really incredible, and this is no small little area. We're talking vast amounts of planetary landscapes here. But, so across this landscape are what appear to be scattered mesas, buttes, isolated outcrops, as well as eroded remnants. Now, most possess irregular shapes that appear entirely consistent with natural geological processes. Okay, anyone looking at that may, come to that conclusion fairly easily. Really a nice feature detailed wonder to look at. Really interesting and incredible. But however, one feature appears different. And I think we could all see that right now. This image was acquired by the Mars Reconnaissance Orbiter mission using the CTX camera, the context camera, although its resolution is modestly lower in resolution compared with more high-resolution high-rise imagery from the high-rise camera. It is still amazing of detail as well as clarity. But anyway, one isolated elevated landform immediately stands out from the surrounding terrain. At this stage of observation, we make no assumptions regarding to its origins. We simply acknowledge its existence. Think about that. So you can see it's clearly there. But the purpose of this investigation is not to demonstrate that an artificial structure exists on Mars. See, there's a twist to this. All right, because all these scientists like to, call names to people who make claims about what they may be seeing on the surface of Mars or anywhere else that's beyond Earth as pareidolia, with mental names to try to, dissuade people from growing the balls to speak about what they believe they may be seeing in these images, more so than following their doctrines of men, their doctrines of science, of where, they don't really boldly go and do really encourage you to think of any and all possibilities. But anyway, so again, the purpose of this investigation is not to demonstrate that an artificial structure exists on Mars. This is something for everyone. Rather, it is to determine whether a particular landform within the Candor Chasma exhibits measurable geometric characteristics that warrant serious consideration of an artificial origin hypothesis. The feature examined measures approximately 1,000 feet across, and it has been independently identified in imagery from multiple Mars missions, including Mars Global Surveyor, Mars Reconnaissance Orbiter, Mars Reconnaissance Orbiter Hi-Rise, as well as this context camera. But because the feature appears consistently across multiple independent data sets, it is interpreted, therefore, as a genuine topographic landform rather than an imaging artifact. The investigation presented here evaluates whether the observed geometry is more consistent with conventional geological processes or whether it displays characteristics commonly associated with engineered structures. Something to think about. We're going to look into this. For decades, planetary scientists have assumed that unusual Martian landforms are best explained by natural geological processes unless some compelling evidence demonstrates otherwise. And I say that compelling evidence is what would draw your attention to something that doesn't look natural to begin with, correct? Mars is filled with those. But this is a reasonable starting assumption for most scientists. However, science progresses by continually testing assumptions against new observations. And the feature investigated here possesses several characteristics that motivated a detailed geometric study. And these include apparent trihedral organization, a curvilinear triangular footprint, persistent ridge geometry, coherent planar surfaces, unusual isolation within the local terrain, and consistency across multiple independent orbital data sets. And none of these characteristics, however, individually demonstrate artificial origins. The question addressed in this study is whether their combined occurrence is statistically and structurally unusual. So, this utilizes imagery acquired from 3 independent orbital imaging systems. The purpose? Independent confirmation of feature existence, which we established. So we have one single image that is from the Mars Global Surveyor, higher resolution than the context imager, lower resolution than the Hi-Rise, and higher resolution than Mars Express, which I wasn't even going to get the data for this because it's even lower resolution than what we got from CTX. Again, it's not that big of a feature compared to other Mars features that we go over on Mars Revealers, Mars Anomalies, and Archaeology videos, right? But it's still sizable, all right? And it still brings in an error question. So this one's from the Mars Global Surveyor, and we have 12 separate observations from the Mars Reconnaissance Orbiter's context camera, or the CTX. Let's take a look at some of these. Interesting. Nice. Great. So the purposes are for seeing, obviously, and studying. The lighting comparison, temporal comparison, regional morphology, and geometric persistence. We also have 2 Hi-Rise MRO images, which is the highest resolution imagery of the Candor pyramid. Nice, huh? So observation 1 shows us persistence, as the landform appears in every independent data set examined that we have looked at. Although image resolution varies considerably, the feature maintains its location, overall dimensions, raised relief, principal bright face, principal dark face throughout all data sets. I believe you all would agree, because you're looking at it. Our observational conclusion, therefore, the feature is real. Observation number 2, this gives us isolation. The surrounding terrain contains dunes, what appear to be dunes, layered deposits, erosional remnants, and cliffs, yet none exhibit the same overall geometric organization as our friend right here in the middle. But this does not imply artificiality. However, it establishes that the feature is unusual within its immediate surroundings. Wouldn't you all agree to that? No matter what side of the fence you may be on, or the sides of the street, or the tracks. Now, observation 3, this gives us trihedral geometry. The feature exhibits an apparent organization into 3 principal regions. These regions converge near a central ridge junction. This geometry remains recognizable under different illumination conditions. Observation 4, this gives us curvilinear triangular footprint. One of the most unusual observations is the apparent footprint. Rather than circular, elliptical, rectangular, or conventionally pyramidal, the feature appears bounded by a curvilinear triangle. This footprint appears consistently throughout multiple data sets as well. So, observation 5, this gives us the ridge network. The principal ridge systems forms an approximate Y-shaped organization. Rather than appearing random, the ridges appear to organize the 3 principal faces. Observation 6, apparent planarity. And let me just, before I go on, let me just show you that there's 2 ways of the geometry this has, and what I just described applies to both. See? So anyway, observation 6, apparent planarity. Several surfaces exhibit relatively uniform brightness, consistent with broad planar facets. Although illumination alone cannot establish planarity, multiple image comparisons suggest that these regions correspond to genuine topographic surfaces, which, again, we already looked at all that data. But now, observation 7 this gives us is its scale. The estimated maximum width of the subject feature's footprint is approximately 1,000 feet. Its height is estimated to be from 550 to 600 feet tall, though much smaller than other no small works of wonder on Mars. Even though this is 1,000 feet across, for the structure itself, or proposed structure, is 1,000 feet. Again, that's pretty sizable. This is larger than the one at Giza. Keep that in mind. But this is not a small boulder. It represents a substantial sized landform. An engineer examining this geometry might note several characteristics. These include efficient load distribution, 3-point stability, shell-like organization, reduced stress concentration, curved perimeter, apparent structural continuity. Importantly, none of these observations establish engineering. Nature can also produce mechanically efficient forms. However, their presence provides measurable characteristics for hypothesis testing. The artificial origin hypothesis predicts that the observed geometry should exhibit internally consistent proportions, repeatable ridge relationships, coherent planar faces, statistically unusual organization, possible recurrence elsewhere, and measurable deviation from neighboring natural landforms. Which it does. But these predictions are testable as well. The geological hypothesis predicts that the observed geometry results from differential erosion, layered strata, fractured control weathering, aeolian modification, and mass wasting. This hypothesis must likewise explain the apparent trihedral organization, the curvilinear footprint, local uniqueness, ridge persistence, and measured geometric relationships. The present investigation that we're doing now does not conclude that the feature is artificial. Okay? Rather, it concludes that the feature possesses sufficient geometric organization to justify quantitative and qualitative investigation. The principal scientific question, therefore, is not, is it artificial? Instead, the question becomes, which hypothesis better explains the complete set of measurable observations? The Candor feature represents one of the more geometrically unusual isolated landforms identified within the examined region. Its persistence across multiple spacecraft, its apparent trihedral organization, its curvilinear triangular footprint, and its isolation from morphologically similar neighboring landforms justify continued investigation. Whether the ultimate explanation proves geological, artificial, or presently unknown, the feature merits detailed qualitative and, again, quantitative study. But the feature deserves serious scientific investigation because it exhibits a measurable combination of characteristics that are not readily dismissed as imaging artifacts and that can be quantitatively evaluated under competing hypotheses. For natural or leaning toward artificial. That's science. And that is what must be tried and tested. But the observed geometry exhibits characteristics that are commonly exploited in engineered structures because of their known mechanical advantages. One of the more intriguing aspects of the Candor feature is that its apparent geometry resembles several forms that are widely recognized in structural engineering as mechanically advantageous. The following observations are presented as engineering comparisons rather than evidence of construction. The question being addressed is, if the geometry were intentionally designed, would it possess characteristics that engineers commonly seek? I think that's a fair question and definitely bodes in the scientific realm, especially for engineering. But the answer appears to be yes. Let us look at 8 points to consider. 1. The 3-point structural stability. The apparent footprint resembles a curvilinear triangular form. 3-point geometry possesses an important engineering property. Unlike 4-point support systems, 3 points always define a stable plane. This principle is used extensively in surveying instruments, tripods, aerospace structures, and precision machinery, to name a few. Tongue-tied there, but a 3-sided footprint naturally minimizes rocking and uneven load distribution. See, this is where you have to keep things in mind when we're dealing with these type of features or anomalies or archaeological prospects on Mars. If the Candor geometry truly consists of 3 principal support regions, it would inherently possess excellent static stability. 2. Curvilinear perimeter. The apparent perimeter is not sharply angular. Instead, the traced outline appears gently curved. From an engineering standpoint, curved boundaries reduce stress concentrations. Sharp corners concentrate forces. Curved transitions distribute those forces more smoothly throughout the structure, in essence making it stronger. But this principle is used in bridges, pressure vessels, aircraft, submarine hulls, shell structures, etc. If intentional, such geometry would improve long-term structural durability, would it not? Now, 3. trihedral ridge organization. The apparent ridge network converges toward a central node. This organization resembles a trihedral shell. All right, 3 principal load paths converging into one structural node allows forces to be distributed among multiple faces rather than concentrated within a single wall. You know, I think many might come to mind when they see the bent pyramid that would be an example of such. An example, you know, of what and why it was designed that way and apparently fixed. But again, we need much more study of that amazing pyramid, don't we? But anyway, engineers frequently employ similar load paths in shell roofs, geodesic structures, and space frame construction. Such geometry increases overall rigidity. Now, 4, apparent planar faces. The principal faces appear relatively broad and coherent in all the data set that we looked at. If these represent genuine planar surfaces rather than irregular erosion, they would contribute to structural stiffness. And therefore, if it is natural, it's adding to the longer life of this so-called natural feature, would it not? Just by being in what it is itself describes. But again, large planar shell elements efficiently transfer comprehensive loads. The principle is widely used in reinforced concrete shells, folded plate roofs, and aerospace structures. 5, shell-like structural behavior. The apparent combination of curved perimeter, central ridge, 3 major faces resembles a shell rather than a solid block. Shell structures are among the most efficient structural forms known. And lo and behold, we're seeing this on Mars. What a coincidence! But rather than resisting loads through massive thickness, all right, they distribute loads throughout the entire surface. This allows extremely high strength relative to material volume. 6, reduced stress concentration. All these benefits, coincidentally, this natural feature on Mars allowed this natural feature to have unto itself? Very coincidental. But one advantage of curved geometry is the reduction of localized stress. Okay? Instead of the abrupt force transfer, curvature allows the loads to flow continuously around the structure. Modern finite element analysis routinely demonstrates this principle. Consequently, curvilinear forms are often preferred when long-term durability is desired. 7, wind loading. Again, they like to say, oh, the winds created all this. You know, all these things that you don't really see and that are not even strong enough, even blowing at 200 or 300 miles an hour, would not modify this surface, let alone move these dunes that we do see very much at all. You would think it would blow you over. Incorrect. Now, but let's get back to other facts. So wind loading. If exposed to persistent winds, a curvilinear triangular form offers several aerodynamic advantages. Compared with flat-sided structures, curved surfaces reduce stagnation pressure, reduce flow separation, decrease turbulence, distribute wind loads more uniformly. And these same principles are employed in aircraft, spacecraft, wind engineering, and marine engineering as well. Importantly, this observation does not imply that the structure was designed for aerodynamic performance, though on Mars, you may never know. But rather it demonstrates that such geometry possesses recognized engineering advantages under sustained fluid flow. Here's number 8, long-term structural survival. Long-term structural survival. The features that we're seeing here have the potentiality of being millions to hundreds of millions years old. Keep that in mind. Assuming a hypothetical structure subjected to millions or billions of years of erosion, one would expect sharp edges to soften, corners to round, surfaces to weather, yet the principal structural framework to remain recognizable, which is as such as we see here. Thus, the absence of perfect geometric precision does not necessarily argue against an originally engineered structure. Instead, one might reasonably expect that an ancient structure to retain only its largest scale geometric organization. This prediction is indeed testable. The geometry observed in the Candor feature possesses several characteristics that engineers commonly exploit because they improve stability, rigidity, stress distribution, shell efficiency, and long-term structural durability. Just be redundant with those characteristics that also include trihedral organization, curvilinear triangular footprint, apparent planar faces, central ridge convergence, and distributed load paths. What a coincidence of nature! Importantly, none of these characteristics individually establish artificial construction. Let me read that again. Importantly, none of these characteristics individually established artificial construction. Natural geological processes are also capable of producing mechanically efficient forms because the same laws of physics govern both natural systems and engineered structures. The significance, therefore, lies not in any single characteristic, but rather in the cumulative occurrence of multiple engineering-favored geometric properties within a single isolated landform. Show us the coincidence naturally. Just saying. But this shape exhibits several geometric characteristics that structural engineers independently recognize as mechanically advantageous. Is the observed combination of engineering-favored geometric characteristics more consistent with natural geomorphic evolution? Or is it sufficiently unusual that alternative hypotheses deserve consideration? And what those alternative hypotheses, even you looking at this, may be weighing? Well, is there enough here to show that nature is so consistent and coincidental to bring this forth, the engineering-type geometry, to bear as a natural structure? Or does it weigh more in favor of it being just that? Artificial, intelligently constructed. Again, when we put it in its isolation, its surroundings, and everything else, this thing stands out, like a sore thumb. But that question is, in my view, a scientifically productive one because it points toward measurable comparisons rather than conclusions based on its appearance alone. This question, therefore, becomes more subtle. If nature could produce one of these characteristics, can it also produce all of them together within one isolated landform? So one may ask, so what data would settle the question? Well, higher resolution stereo DTMs, digital terrain models, independent photochrometric reconstructions, multiple illumination, angle analysis, quantitative comparisons with nearby landforms, statistical tests of ridge orientations, and phase planarity spectral measurements to see whether the feature's material differs from surrounding outcrops. But future orbital imaging with improved resolution in situ exploration by a rover or aerial platform should such missions be, ever become feasible. Drip, 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 turtleneck, snail pace speed, policy agenda. They do not want to actually find that life, even though they keep claiming that they're spending our billions and billions looking for that answer. But we know all too well, those in this field, that NASA just runs away from it. That's why we're not seeing missions of this publicly common sense scientific questions. But whether the Candor pyramid feature ultimately proves natural, artificial, or something in between, a rigorous framework like that would have value on its own. But at present, the available imagery does not conclusively resolve the question, but what it does show is a persistent landform whose geometry invites careful measurement, which we've done, and continued investigation, which we're doing. Science advances not by avoiding difficult questions, but by testing them. And people that love to go against and ridicule the people like myself that claim pyramids of Mars, etc., and other artificial or archaeological features, which are both, again, redundant, love to use the science and NASA words, but not actually do the science. So this study comes at it a different approach to where it forces them. Is it out of bias because there, or can you use science to test these things as I'm laying out here? Using science to make one think for themselves. And they don't have to be that fucking smart to see that there's more characteristics and geometries within this self that would favor, in my opinion, an archaeological artificial construct. Okay? There's more pointing to that. Well, and the science proved the model then that all of these coincidences naturally is what proved it. How can you show that model to prove this when you really don't even know what created it? So, anyway. So science, again, advances not by avoiding difficult questions, but by testing them. Ignoring Morse completely, if you saw this geometry engineering in an engineering context, what structural characteristics would you notice? That's a fascinating question because it asks everyone to evaluate the geometry itself rather than its origin. Okay? Because this is imagery and that's of data being seen, something that's definitely there. It's not an artifact of coincidence or some photo bloop, that just of low resolution. We've seen from lower resolution to high resolution. This thing is incredible, and it's got, again, why explain it? You're looking at it. But the Pyramid of Candor is simply one of the most unusual erosional remnants on Mars. I think everyone would agree to that. Perhaps it preserves evidence of natural processes we do not yet fully understand, or perhaps it represents something entirely unexpected. That is, it is indeed an ancient artifact of archaeological wonder. History reminds us that science is not advanced by dismissing unusual observations, nor by accepting extraordinary claims without evidence, or extraordinary evidence. This is some extraordinary evidence, if you ask me, but it advances by investigating anomalies carefully, objectively, and honestly. Every major scientific discovery began with someone willing to ask a question that had not yet been answered. And I always say, listeners to my show and other venues and forums, and all I've been saying for years, you can't find nothing if you're not looking for it. Common sense. And there's things to be found there. And therefore questions that demand to be asked and answered. Scientifically, rationally, and truthfully. But perhaps the Pyramid of Candor is an unusual geological formation. Perhaps it represents an ancient structure. Or perhaps the truth lies somewhere we have not yet imagined. Whatever the answer, the investigation has only begun. Thank you with your patience in allowing me to present this study to you all. And I am asking you only to think for yourselves and think with unbiased attentions. In my opinion, I believe by the data seen that this is an intelligently created ancient archaeological technosignature. What do you all think or have to say about this one way or the other? Please leave your thoughts and comments, and I humbly ask you all to please like and subscribe to this video and to my channel, as this is your destination for alien archaeology, and I need your help to make it grow, especially when you're being shadow banned by CommieTube and other commies around the planet that think that only certain people have a right to speak and to show. But as long as you follow their touted policy public lines, then you're good to go. But there was only one true Mars disclosure. So please like and subscribe to my channel. And we'll end this presentation with a 3D viewing of the Pyramid of Candor, bringing the two-dimensional image views to life to better see and understand what it is that we're really looking at from a two-dimensional imagery of data, and help better appreciate overall this incredible Martian anomaly. Well, until next time, peace.